Okay, I'm recording now.
Okay, you got that?
Yeah, I usually jump this stuff.
And you know what? I made you co-host. How about that?
Yay.
Now that means I probably lost it.
That means you're in charge now, Randy.
You're in charge. Wasn't you're in charge. What kind of a hat is that, Phil?
It's a Keats hat.
Okay, I'm going to say
It's
it looks
festive.
looks more like a Paddy's Day hat than a.
Well, yeah, but it's got red and green in it and some white too,
I
right?
guess. Okay.
So,
Yeah.
Any excuse.
okay.
Okay.
The festive drinks. So
You can
yeah.
have Keith at any time.
Hello,
Yeah.
Chris.
Yeah. See my new
Who's
hat?
iPhone?
Ho, ho, ho. Merry Christmas. Have a jolly Christmas. Anyway, let's get serious now.
Serious.
Yeah, it's just below
That's a
the
star,
Orion belt.
isn't
If you take the Orion belt and go back, yeah. Oh my! Welcome to the St. John Center RASC annual. No, it's not the annual meeting. December meeting. I think I should have stopped drinking before I got on.
No.
I'm Gary Diamond. I'm the president of the St. John Center. I want to wish you all a Merry Christmas and a Happy New Year. And it seems like the year coming up may be better, seeing I've heard on the news lately and all that.
It will be better.
Yes. We'll all be getting our shot. Not tequila, something much better. I'm going to get the agenda. What's the agenda, Randy?
The agenda right now. Gary will do introduction, introduce speaker. Speaker is Kim Hay. Gary will thank the speaker.
All right, that's quick.
Then we have observation reports. Nikolai will do his sky this month, and I don't know of any other business. So
yeah, I got astronomy stuff up. Pictures people took. Okay, I'm going to ask everybody to press on their mute button so we don't have any background noise when our speaker is speaking. This is something new. We actually get to see each other's face this time rather than the webinar. I've had a lot of requests that people feel more part of a meeting when they can see each other, look how ridiculous we look and try to pretend we're really interested in things, especially when I talk. Stop the yawning there, guys. It looks very bad for me. Now, our guest speaker tonight, I've known for years when she was the national secretary, and she sent me a very nice letter congratulating me on doing the 110 objects, finest objects, NCG objects. And she's also been a member of the ALPO, which is the American Planetary and Lunar Association, where she is now acting director, I think. She used to be director at one time.
Yep.
She's also a member of the American Meteor Society, International Meteor Society, Variable Star.
Yep.
Yeah. Geez, you and I have a lot of things in common. We like to like to join a whole lot of things. She has a keen interest in meteors, because I know her from meteors, and she has a keen interest in solar observing. And I've noticed that our membership has a lot of solar filter telescopes, probably bought for a coming eclipse next year, or next 2 years, 24. And we have about 6 or 7 people who have H alpha telescopes with our group. So I thought I'd get her to tell us about solar observing and try to get us to become more involved and send off our things rather than just talk about it. So without further ado, I'd like to introduce the president of the Kingston Center, Kim Hay. Take it away, Kim.
Thank you all. Thanks for having me. This is great. I'm going to try sharing my screen. Let's hope this works. Okay. PowerPoint. And let's see if we can do from the beginning. There you go. Much better? Anyway, we'll go through it.
Yes, it is.
So solar observing. becoming a citizen scientist. Since some of you are actually solar observers, this might seem to be repetitious, but hopefully we'll be able to get you to submit your results and actually participate in citizen science. So some of you may have seen this picture. This is from APOD from September 1st, showing cycle 24 when it was active, when it was dead. This is coming out of the cycle. So therefore you're seeing two sides of the sun when it's active and non-active. Now, it was noted December 14th, 2019 by NASA that was the end of cycle 24 and we were beginning in cycle 25. And in the spring of 2020, there were groups that represented both of the cycles, but the magnetics of the groups showed that they were coming from cycle 25. This is the solar cycle 25 forecast update. As you can see, cycle 23, cycle 24, which had a hump in the middle. We had two small peaks in the cycle. And then they're predicting that 25 is actually going to be about the same as 24, if not more smoothed out. It might not have the two peaks that 24 had. The southern sunspot groups at this time are actually taking over. So the southern hemisphere of the sun is waking up more than the northern hemisphere. So we're actually having a lot more sunspots showing up on the southern hemisphere than the northern. We've had a few, but not a lot. And this is basically just a graph over the last month of sunspots that we've had that shows that around the 29th, it peaked, and that was when we had a M-class flare, and we ended up having aurora. We did not in Southern Ontario, but you may have if you had clear skies. So it's just showing what the sunspot is still very erratic, but they are coming on. So some of the solar history. 1848, Randolph Wolf, famous for the Wolf sunspot number, created the calculation of the number of groups times the number of spots would give you the number for the day. And the AVSO uses the American relative sunspot number, which is basically the same formula, but it was set up in 1944 because they couldn't get any data out of Switzerland because of the war. So Wolf had searched through all of the available sunspot data, and he made the correlation between the groups and the spots. And then after becoming the director of the Zurich Observatory, he initiated the program to measure the daily R factor. And to this day, Zurich Observatory has remained the world center for solar sunspot numbers. So some fun facts about the sun. Our sun is a yellow dwarf. It is a variable. 150 million kilometers from Earth. Here's our little sun on the Hertzsprung diagram, just in the middle, just hanging around, having a good time. This is a picture from NOAA that actually shows the spinning of the sun. And generally, what happens is sunspots will start at the upper and at the lower end of each hemisphere and come into the middle. By the time they get to the middle, that's the end of a cycle. So this takes over 11 years to do. Our sun is 4.5 billion years old. And the sun takes 27 days to rotate, but can vary because of the latitude, as you can see here. Sun's rotation and the butterfly effect. Basically what we're seeing here is sunspot cycles. These are the solar cycles. So the sunspots start up at the top and they become active. They come into the equator and they dissipate. And we end up going into another cycle. And we're at the minimum. Since it takes 11 years, but it can take 8 to 14. We've had some sunspot cycles back. I think it was cycle 8. It was only 8 years. So how to observe the sun? Well, what can I do to enhance citizen science? Well, you're already observing it, but what you need to do is be able to send your data in so it can actually be incorporated into the world data. So you can do white light, counting the sunspots in the groups. And this can lead to understanding the morphology of the sun and how the whole system works. I mean, you have a sunspot like a pore that can turn into a sunspot. Then it ends up with, so this is the umbra. Then you have the penumbra, which is actually, this whole thing is cooler than the sun. That's why it looks so dark. You can do H-alpha, calcium K imaging, and each have their own distinct qualities. You can do solar sketching. You can do pastel, watercolor. It's also done for all three of these wavelengths. Advanced imaging, which some of you already do, is with the calcium K and hydrogen alpha. The calcium K is only used for imaging because it's at the high end of the violet spectrum and our eyes cannot see it because of the yellowing of the cornea. CMOS cameras are now are what is used. I've currently just started getting into hydrogen alpha, and I'm using a monochrome camera, the ASI-120mm. I have a few images, but I'm not ready to show those yet. So you're never too young or never too old to learn. Warning, never observe the sun without your telescope having proper solar filters, ever. Glass, I've got solar filters I'm going to show at the end of my talk because I have to unshare the screen. Glass such as a Thousand Oaks solar filter that gives the sun the yellow-orange color that you see here. Solar screen, which has replaced the glass filter, and it gives the yellow-orange color. And Bader film, which is generally used for making your homemade filters, and it gives a white appearance and it gives a good contrast on the groups of the umbra and the penumbra. So the AVSO actually uses the relative sunspot number. Again, it was created in 1944, the program, and how is it calculated? Our number of groups times the number of spots will give you a number. The sunspot numbers that the AVSO compares against are from CILSO, and basically they are the world-renowned collector of data. These are created monthly, and the AVSO produces a solar bulletin along with all of the solar observers' data around the world. We have last November, well, November's solar bulletin, we had 1,114 observations from 68 observers from around the world, including the Solar Dynamics Observatory. Yes, they get to be included too, and that's amazing. They're the only ones that have sun every day. So and you don't need to be a member of the AVSO to submit your data. All you need is the solar observing code. You can go online and you can request that and you'll get it. You can download the sun entry program to input your data. You just need the total, or you can count both the south and the north spots and the groups. You have to set up your header information of the equipment you used, try to keep your observation around the same time daily, keep the same equipment to be consistent. Again, we know to observe when the sun's above 25 degrees, but not overhead when the sky is very turbulent, and keep out of the murky skies when it's low in the horizon. And the report from the AVSO is created monthly. And if you want to go and view that, you can see it at the AVSO website under Solar Bulletin. So this is an example of the Solar Citizen data. This is what I do. This is November's data. So basically, sun entry, you input your data information of what you're doing, the day, you measure what you're seeing was like. The time is always in UT. The number of groups, the spots, there's your wolf number. And then you can separate it out as how you saw it, whether it's in the southern hemisphere or in the northern hemisphere. And you can put in some remarks. This is actually collected monthly. And at the end of the month, I end up running this report for the AVSO that creates the file for the bulletin. And at the last annual meeting this year, I just received my Solar Observer Award for my 3,000th observation of observing the sun since 1999. We all know what our Canadian weather is like, so that tells you how long I've been observing. So here's another graph where I've taken, this is the SILSO numbers of the data across the world. And this is the sunspot numbers and how it goes up. So remember that graph I showed you before, where at the end of November, it was very high, it was peaked. And this is my data based on 13 data points. So basically my graph looks the same, except I don't have enough points, but on November 28th, I peaked as well. So I do have the peak that had the M4 class flare, but we didn't see the aurora. For the radio astronomers in the group, apparently there are some radio astronomers. There's also the SID program, the Sudden Ionospheric Disturbance, and that's run by Rodney Howe. And this is the VHF data that's recorded by observers using various radio stations throughout the US. And it's compared up against the GOES-16 satellite, where if you got a SID, hit, you'd compare it against the GOES, because they're always receiving that data, and you can compare to see whether you actually got a sudden ionospheric disturbance. And that is also included in the solar bulletin. We here at Starlight Cascade are running a SID antenna and project, but we right now we're trying to get it converted over to Raspberry Pi. So if there's anybody that's in the St. John Center that's actually doing radio astronomy and using Raspberry Pi, if you could get a hold of me and let me know how you're doing it, because we're running into some issues with some of the programming. So that's the AVSO. Easy for you to do. Download the program, input your data, do it daily or whenever you get to see the sun, and you're actually contributing to citizen science. You're actually in on the ground floor of Solar Cycle 25, so this is great. So then we have the next group, which is ELPO, and I'm acting coordinator. I write the Carrington rotation reports monthly. I've been doing that since I started back up in the group again. And basically it just talks about what happened for the month, how many flares we had, how many people submitted observations. Basically the ALPO has the largest image repository of sunspots, flares, light bridges, the study of the morphology. Or a couple of our observers caught the Helleman bombs in October. So it was quite interesting to see that on their images. I've got that coming up next. So each rotation, of course, is based on the sidereal rotation period of 25.38 days, but it can vary, depends on the Earth's orbit. Carrington rotation was started by R.C. Carrington back November 9th of 1853. And back in cycle 21, ALPO solar section was born. So it's been going since then. Carrington rotation numbers basically are produced by a program called WIMP by Jeffrey D. Bish from the ALPO. And here's an example. So currently we're in Carrington rotation number 2238. And it gives us the date that it started and the date that it will end. And 2239 is coming up on Christmas Day. That's the next solar rotation period that we'll be in. And if you want to take your pictures to be included in the ALPO gallery, solar gallery, please send them, go to the ALPO website, look under the solar gallery and see how they're submitted, and send them to the group. And plus we also have an email list at groups.io, and look for Solar ALPO, and you can submit your observations there to let everybody see. We currently have over 76 participants on that list, and it switched over from the Yahoo group, which Yahoo stopped doing email, so we switched that over, and it's picked up pretty well. And of course, with the sun being more active, we're getting more people coming on. So examples of images of white light, H-alpha, calcium K, and sketching. This is Theo Ramekers. He's from Alpo, and this is basically white light. Of course, he does processing to make it the yellow color because he uses a monochrome camera. This here is white light as well. This image here by Hank Bartlett, he actually uses his DSLR and puts it into his Solar Max 60 as a double stack now. And he just got himself some continuum filters, and he's only tried it out once. But this was basically a hydrogen alpha, and he does the processing in order to give it the color. David Teskey actually does hydrogen alpha and sketching. So he'll draw the sunspots, plus he'll look at hydrogen alpha, and he'll put any of the prominences or the filaments that he sees on the same sketch. This here is by Theo as well, and it is H-alpha. I'm blown away by these images, just to see the detail that these cameras are bringing out on the sun. It's just amazing. This is by Howard Eckelson, and this is actually, I think this is the, he's using a Lunt system and double stack, and I think it's hydrogen alpha. I did have some calcium one as well. I'm just blown away by them. And of course, solar observing, and the sun is part of space weather. I mean, we all know that. Solar flares from the sun carrying the solar wind project to the earth, excite the upper atmospheres and produce aurora, both in the southern and the northern hemisphere. Much like we had November 29th, like I talked about, there was the M-class flare from sunspot AR 2785, which also produced a partial radio blackout in northern Ontario. In this past week, last week, there was the massive talk about the massive aurora that was going to come and over Canada, and we were going to get aurora all the way down to the 45th and the 44th parallel, and yeah, it fizzled out and we got nothing. So, but for more space weather, you can go to the space weather at NOAA. There's also space weather woman, Dr. Tamitha Scove, who actually teaches space weather at Miller University. This is the first year she's done that. But she has her website, which is listed here, but she also does podcasts online as well on YouTube, and talks about the space weather, and talks about, sometimes she actually does Martian weather, and talks about the radio propagation and how it helps everybody, ham radio operators and first line workers that are using radio communications. And then, of course, Carrington events back in August 28th and September 2nd of 1859 was a big Carrington event where the power that they did start having was blowing up. There was no light. It was a giant geomagnetic storm that happened in solar cycle 10. And the Quebec power outage in 1989, it had 90 seconds of darkness, but it was because of a CME that hit the Earth. So, I mean, space weather is out there. It can come and get us at any time, and we have to be mindful of that as well. So, main thing, of course, is to observe safely, use your solar filters, but have fun. Take time to scan the sun. Use a grid pattern so that you can see pores or spots or depressions like the Wilson effect. This here, I don't know if you can see me put my mouse around it, but on the top picture, on the edges of the sun, those sunspots that are coming on and going off, those are depressions that look 3D. That's basically the Wilson effect. Then there's the Ellerman bombs, which is this on the bottom picture. You see the bright white. That's basically, it's plasma that's coming up, then it's different opposite magnetics of plasma coming up, and they're brightening and they will flare. So the sun is full of action at any given time, even if it is in minimum, because the pores and the granulation on the sun are really something to look at. So come and observe and report your findings. If you have any questions, please, send me an email at canadianspooky@gmail.com. I'll help you. But we'd just like to get your data out there. Don't hold it to yourself. Show everybody in the world what you're doing, because it's great to be part of the journey of the sun. So I have one page here of links that if anybody's interested in them, I can send them to Gary and he can send them out to the group. And if you want more information to become a citizen scientist, RASC, the Observer's Handbook, on page 168 to 186 to 188, I have that. Solar Sketching, a comprehensive guide to drawing the sun, the Patrick Moore Practical Astronomy series. I was part of writing that book as well. Whoop, I've lost my, hold on here. Too much scrolling with the mouse. The BAA also has an image gallery and a sunspot collection form, but you must be a member in order to send your data in there. Today at 2 o'clock this afternoon, I was actually watching Sherry Carl, who does observe the sun in the 3 wavelengths, and she gave a great presentation. So if you want to go on to YouTube and look under the BAA channel and take a look, you see what she's doing. And thank you for the invitation to speak to you, and I hope you enjoyed the talk. I'm going to stop sharing now. Oh. I do have some, I have some filters that I talked about. I just want to show them to you. So this one, of course, is the glass Thousand Oaks, which gives the orange light. And you know that you always have to check your solar filters in case they end up with holes and that sort of thing. As you can tell, there's little pinholes in this. That's why it's got the black dots on it. I don't use that one. It was replaced by this one, which came from Thousand Oaks, but it has the solar screen now. So they don't use the glass anymore. And it's about the same price. And again, it gives the orange vision of the sun. Then you have your your Beta film. This is for the 80mm refractor that I have, that I'm using. I have it set up on the Ioptron mount along with my Solar Max 60, and I'm trying to get them both in a line and having lots of fun trying to work with that. If you're taking images with your DSLR, of course, you can still get a 58mm solar filter for your camera. And this is what we ended up using for the eclipse when we went down to the States in 2017. And we saw the total solar eclipse. So we took pictures with this. And also this is, see, sketching and painting and using colored pencils of the sun at various times, doing hydrogen alpha. I just wanted to get another one in here. Just to show you, just basically just graphite. That's all I used for that was pencil. So I usually use watercolor, crayon, or color pencil, and graphite pencil in order to do the sketching of the sun. So now I sketch them and I take images with them and I view it visually, and hopefully you can all come out and start submitting your data, because I'd like to see it. Thank you. Thank you all.
Thank you very much. I had asked Chris to check the chat line. I don't know if he got my email to do that.
Oh, you go ahead and
for questions.
You got questions?
Chris? Are you looking at the lines?
Okay, can you hear me now?
Yes.
I hear you now.
Okay, a while ago, Phil asked, hey, Kim, congrats on the solar award.
Thank you.
How long does it take to make a typical solar observation on any given day?
I generally spend 10 to 15 minutes, especially if I go and I look at a couple of the websites. I don't like looking at them before I look because that'll prejudge. You'll start thinking, okay, yeah, maybe I saw a spot, but you may not have, right? So I tend to look for a good 10 to 15 minutes. I'll zigzag across the sun. I'll do the grid format, check the edges. I check for flage. I check for pores. I check for sunspots because as they're coming on, you may, a space weather may say, oh, there's a new sunspot coming on, but that was in the morning. Well, it may have rotated on by the afternoon. And generally I do most of my sunspot observations. I've been doing them in the afternoon because I did them after work. But now that I'm retired, I'm now doing them in the morning. So I can actually set up and do my white light, the hydrogen alpha, spend an hour or two in the observatory. And so, yeah, you can do it fast or you can just take your time and get your information.
Thanks. Only one other question, and it's from Meetings RASE to everyone. So I don't know who sent it, but maybe it's from everybody. Does using a yellow filter increase contrast of sunspot in visual white light?
I like it better. I use both. But I tend to use my Thousand Oaks orange filter more often. If there's a lot of if there's a lot more sunspots, I'll tend to use the Beta because it will show the penumbra a lot more. But if you still have your Beta film, you can actually put in a 58 filter, green filter into your eyepiece, and it'll give you the orange color. So it depends on what you want, but I tend to like the orange better. I see a better contrast with it.
I took a quick shot of the sun a few weeks ago through Beta film, and then I used image processing to make it yellow. But anyway.
Yep. A lot of people do that.
Another question from Phil. Have you ever seen something that really surprised you on the sun?
I was looking for the light bridges in the last sunspot that we had come through. I think it was 2786. Had light bridges. And I was impressed that I could see them. And in the last, well, actually Monday, I was out doing some hydrogen alpha work with the new camera, and I was amazed that I could see the new sunspots that had just come on, which was 2792 and 93, but I could not see them in the Beta, but I could see them in the Thousand Oaks. So it it's whatever your preference is, but I tend to like, I was surprised that I could get detail in the hydrogen alpha. That was fun. And of course it's been cloudy ever since.
Typical. I have a question if there's any one. What size telescope are you using to observe the sun?
My main telescope that I use is a 100mm Schmidt Cassegrain. So basically 4-inch, this size. Anything bigger, you would want to stop it down. So you'd want to make an aperture filter and have a smaller solar filter. I do have an 8-inch Dobsonian that has a solar filter for it. And basically it's like this big because anything more, it just blows it out. You don't need that much aperture. And then I have an 80mm refractor.
I'd imagine you're looking through more atmosphere with a wider aperture, and in the daytime, the atmosphere is a mess.
Yeah,
so,
definitely. Yeah.
Doug, our Doug Grushi asks, or actually says, "Great talk, Kim." And then he asks, "Have you ever used a sun spotter?"
Yes,
and
I
I think
have.
that's a device with the 3 mirrors.
Yes, yes, I have. I actually borrowed the sun spotter from Queen's University when we were writing the book, and was actually setting it up to do the sun spotting of the sun, so that I could explain how it was used and take pictures of it. So yeah, I have used the sun spotter. It does work. It's a great little projection telescope, and I have done solar projection as well. So you have many ways to observe the sun, and you don't need a lot of equipment. And you can submit your data if you're doing it by projection as well. There's no problem with that.
Kim, I saw that you can observe the sun at night now. You just need a solar neutrino observatory.
Yeah, really, eh?
Did you see that picture?
No.
Yeah, they posted a picture just 2 days ago.
Oh, okay. Was that on?
Looking through the Earth, right?
Oh, okay.
Yeah.
I'd have to find that one.
Yeah.
That sounds good. That would be great if we could, right?
You mentioned your mount. You got an iOptron mount?
Yep. Yep.
Which one is that?
Let's see. It's the iOptron Pro.
Okay.
But I'm having issues with it where I have the 80 millimeter on the main mount side, and then I have the extension tube that holds the 60,
Okay. Yeah.
the SMM 60, but I'm finding that it's slipping.
Yeah.
So we either have to put Loctite on it, or
yeah, you can barely touch that and it goes unlocks. That's
yeah,
the biggest problem with that. I picked up a version of the AZ Pro, or the AZ GTI, which is only solar. It's got a little camera,
okay.
and you just turn it on. You don't need any software. It finds the sun and tracks it.
Good.
So it can take my Lunt 60 double stack easily. So it's no big deal. So
that would be nice to get.
It worked great for the Mercury transit last fall, right? So
yeah, we've seen both Venus transits and the Mercury transit, so we've been very lucky.
Yeah.
Yeah. That's great. I'm going to stick around and while you do the rest of your meeting, because that's what I want to do.
You're more than welcome. Thank you very much. Very eye-opening. I use a 60 for my white light, and I have a 35 hydrogen alpha loop for my hydrogen alpha stuff.
Good. So you're going to start submitting data, right?
Yeah, I guess I might. I think I better do that. I used to, and I started giving up.
He needs to retire.
Yeah. Yeah.
Yeah, that's right. Yeah, you sort of get it and you say, well, do you really want to send it? But I mean, I send all my Mars stuff and my Jupiter stuff all the time.
So why not?
And Venus. I don't know. Sun just, I got all this stuff and type of thing. Take a lot of pictures. Go ahead.
Oh, one quick question for Robert. Sorry, it came up. First of all, Marcellus says, thanks, Kim, for an enlightening talk. I don't know if there's a pun in there somewhere. And Robert asks again, why stop down a larger scope? And I think we answered that, but I'll let you answer it again.
Because you're blowing it out. There's no sense of having a larger scope. The sun is so bright that you have to take it down. You have to make it smaller to see it. So 4 inch is an excellent size, 125 millimeter. I wouldn't go any higher. People that I know that have larger scopes stop them down and use a smaller aperture for the solar.
Hey, Kim, I have a question. I've got 11 by 80 mounted binoculars with appropriate solar filters on the front end. Are those appropriate for doing these kinds of observations, or are we still kind of hurting for magnification for some of this? They're 11 times, right? So
yeah, you may be able to get if there's large sunspots, you may be able to get it. You can try doing some solar projection.
Yeah.
With them. I know we tried using the binoculars for solar projection when the ISS was going across the sun, and it worked. But the ISS goes so fast that it's blip, it's gone. But it does work. So I would try it. Just give it a whirl and try the projection to see how that works.
Okay, I last used them for the Mercury transit, and you know, you could see it, but you know, and I could see some spot at the time as well, but you know, it wasn't that detailed.
Right. You may not get a lot of the detail because you do need a little bit more magnification. With my 100 millimeter telescope that I use, it's a 1200 millimeter size, but I'm looking at it at 46 power.
Yeah.
So generally, if you go about 50 power, you're doing pretty good.
That's good. Yeah. Yeah, I've got an 8-inch Dob, but no filter, so.
Well, make your own.
Yes, I do have. I do have the filter to do that. Yeah.
That's what I did for our Dob. Is we've got the the front cover. Well, you've got the front cover, and basically it has the two caps. I took them off and I made a filter to cover both of those holes. So it's when they come together, it's only the one.
Yeah, I'd have to.
Or sometimes I cap it and I just look through the one.
Buy your filters in the next year or so before the craze hits again for the 24 eclipse.
Yes.
It's going to be crazy like it was for the last one.
Yes. Has anybody decided where they're going to go?
We'll
be able to travel by then.
Yeah, we're all going to Terranova Park, right?
More or less stay put.
Yeah, it goes over us, but I mean, I remember back in 1970 when it went over us in March. It was a rainy day.
Yeah.
And we have a tendency to have cloudy weather. But Nikolai had said that he was looking at it, and if it's cloudy in Terranova, usually the west coast, where you still be able to see it, will be clear. Could be clear. He said, looking at the weather over the past years. Is that right, Nikolai? If you're still there.
It's a possibility.
Because I'm thinking about going to the States to tell you the truth.
Yeah, a lot of people are talking about Texas. They're going to Texas. Yeah.
Yeah. We were stuck in the 12-hour drive home from it was supposed to be a 2-hour drive when we left Denver, but going back took us 12 hours. We got stuck in that worst traffic jam ever.
Yeah, we ended up observing the sun down, the total eclipse down in Wyoming.
That's where we were.
And we were in JM.
We were in Douglas.
It was amazing because we left at 4 o'clock in the morning and we drove down from Devil's Tower because that's where we camped. And that was a beautiful camp there. The second time we've camped there. I'll go back again. And
did you see any aliens though?
Oh, only when we watched the Close Encounters. Yep. We left at 4 in the morning and got down to JM. So I mean, we were there, a good hour and a half before it even started. So we were waiting first contact, second contact, the whole thing. It was just amazing. I still get goosebumps thinking about how the dark it got and the birds that came out in the sky and the stars that came out.
Oh, wow.
And the sun itself. And I was shocked. We were both shocked that once the totality was over, people left. People got in their cars and they drove away. We're thinking, well, it's not done yet. So
they wanted to load our buses up, and it's all we could do to stay till it was finished.
Yeah, it's just like amazing. And it was after it was over and we talked to people for a bit, we left, but we still were in a traffic jam. And then we ended up going into a small town and we ran into Jennifer West from Winnipeg Center. She was there. And so she had just was driving down to start living in Toronto. So we're meeting people from the RASC all over the place. So yeah, it was fun. So we don't know where we're going for the next one. That's still up for discussion.
Yeah, we were in a cow field with 18 buses, and the bus had one side, they had a bar and a cafeteria, basically, and dancing, So people were dancing away, and we were on the other side taking pictures, going, "Are we missing something here?"
So here's my sketch of the solar
wow.
eclipse.
Oh, wow.
So I was trying to do this in the dark, and so that's what I got. That's my sketch. So, and plus, you know, we were writing down all the times of everything, and we were taking temperatures through the whole event. Yeah, we were following the temperature, and we ended up doing a temperature graph of how it went down and then went back up again. And yeah,
I caught solar bands on my video. Oh, I was very proud. Anyway,
back to the meeting.
Meeting, yes. Okay, Randy, what's next? I want to thank you very much. I also need your mailing address, so you can email me that, because I
no problem.
Have a gift to send to you. I think we do we, Randy?
Yes, we send a little memento to our speakers.
Good. Send us some clear sky.
Sorry, we're keeping that for ourselves. The problem we have, Kim, is like tonight, it was clear, perfectly clear for the sunset, but 95 click winds, right?
Yeah. So. Yeah, it makes it hard to try to take pictures of the planets, that's for sure.
Okay, well, thanks, Kim. Gary, next is call for any observation reports.
Okay. Okay.
I've got one if you want to see it.
I got now I'm going to share this, Randy, because I think I took your picture and put it up.
Okay.
Okay, as soon as I figure out how to use this computer again. Share my screen. Okay, let's see.
I think Chris just posted one as well.
Yeah, I think you bet me to it, Randy, and yours is a bit better.
I got yours too, I think. Well, no, I got yours yesterday. Can you see my screen?
Yep.
Yep.
Okay, let's take it from the beginning. Astronomy stuff. Okay, Mike, this is your Mars picture. You want to open your mic and tell us about it?
Okay, well, it's another Mars picture, but I've been doing lots of pictures of Mars using my DSLR on the 8-inch Dob, which means you have to sort of chase it around. And so this one was actually one of the first ones I've tried on my 80mm refractor with the tracking mount. And so I also had the Barlow in, but the so like it says 44 frames. I think it's a lot more than 44 frames, but it'd probably be 800 frames or something like that. On the DSLR, for the video, it has digital magnification, which I think what it's doing is doing less binning of the pixels. And the problem is that it doesn't stay on if you aren't doing things continuously. So I had it set up with more magnification, but I think by the time I actually got everything tracking and working, it had gone back to normal. So it's something I want to try again. You can see a little bit with it, but not much. Anyways, that's what that was. So that was sort of an experiment using the refractor, and I even thought about trying it again tonight, but it was too windy.
Thanks very much, Mike. Okay, Chris. Okay. I'll ask others to turn off their mics when they're finished so we don't get feedback.
I'm here. Sorry, I was just finding this homemade Botter film filter. We made these at Star Party. Gary, you remember that?
I suppose. I'm getting old, buddy. Was that
no,
the last, the new Star Party?
Only a couple of years ago, I guess.
Oh, yeah. Okay. Yes. Geez, yes.
Yes. So, and it works. So, and I made it for one lens, and it happens to fit on another lens. So this was, when was this? This is a couple of weeks ago.
Yeah, November 30th.
Yeah.
Oh.
And the advantages of working from home. It was a somewhat clear day when I tried to take the picture. Of course, it cleared off completely once I finished the picture and posted it. But I took this between clouds, and it's just this camera, and the filter turns out to plug onto the camera very nicely. It's a motion compensated lens, so I literally just stood outside in the driveway and took a 1/4000 second exposure, or a bunch of them, and then picked the one that was sharp, and touched it up a tiny bit in the computer, and that's it. So I think yeah, when I posted this, I commented on the numbers of the spots. I forget the numbers. There are a whole lot of little ones there. You can see the two bigger groups. So somebody asked you, Kim, how long does it take to do an observation? So in this case, I went out my driveway in my socks and a camera and took some pictures in a few seconds and then hopped back inside. So in this case, at least gathering the data took seconds. Anyway,
Okay,
sun's heating up, I think.
I got another one here.
Oh yeah, that's another. Before the snow fell, yes, I was out in the driveway in my socks again. I have a little observatory in the backyard, but we have a lot of trees in the backyard, and Jupiter and Saturn were off limits all year, which was frustrating. So I couldn't take any pictures of them. But with the same camera, but without the filter and the longer exposure, I snapped Jupiter and Saturn last week, I guess it was, or not even that. It was the 12th, December 12th, I think. So.
Okay, thanks, Randy.
This is just a quick one this afternoon. Just start to see a bit of earth shine on the moon there. That's not a very good copy there on my screen, at least. Yeah, like I said, this is 95 winds, like you got there, 60 to 80. So after a couple of minutes, my camera froze, and that's what I got. When I zoom in, I can tell the difference between Jupiter and Saturn, and a little bit of fudging around, you can actually see more of the Earth in the moon. So that was just a quick one. Who knows whether we'll get anything more between now and Monday.
You can actually see Jupiter here, and Saturn's this one right here.
Yeah.
And this is the moon.
Is that what...
I took one, but I had more clouds down here and here. So I'll let yours go. All right, Jim. Go ahead, Randy.
We've had a lot of teasers, like you look out and it's cloudy, you look out again, there's a little gap between the cloud, you can see the two of them. So I've seen almost every night lately, not a lot of change though.
Mm-hmm. Okay. Jim, are you there?
Yes, sir.
All right. I see you're working on your Messier list.
Yeah, I'm trying to get it done. Actually, I didn't realize how many I had actually captured until I actually went and did that little spreadsheet. I've actually got exactly 1/3 of the Messier objects imaged.
Way to go.
So I believe this night I was basically it wasn't going to be the greatest night for imaging, so I decided just to see how many open clusters I could capture, and I ended up getting 1, 2, 3, 4 in one night, so it was pretty good. And these were all taken with the Explorer Scientific ES 127ED and the ASI 183mm Pro, and they're just LRGB images.
Okay, here's the next one I got here.
Yeah, so I guess you just go through them, and that'll be good.
Okay.
I think they're all about an hour
Guys,
exposure each for all of them.
Okay. A lot of, okay. You want to talk about this?
Is this the video or is this just
Yes,
the
this is the
single
video.
image?
I'll see if it works.
Okay.
But I thought you might want to talk about it before I press.
Yeah, so actually myself and Robert were on this night, and this was all captured when I was out here offshore, using my remote setup that I do. So yeah, this was the night of the eclipse, the November 30th. It didn't start until about, I think it was, we'll sit there on the screen, 3:55, and ended, well, obviously for us, it ended at sunrise, just as the moon was setting. So it was only about halfway through at that point. Which I ended up doing a time lapse. And I thought that was pretty cool. I think it got overly exaggerated the darkness at near the end because where the moon was setting.
Yeah, because I didn't notice it that dark visually. I was watching it visually.
Yeah.
Okay. We can let it go one more time so people who were.
Quick, I can get my lunar observing certificate. Slow it down a bit.
At least you can pick up your rays and your oceans, marinas.
Yeah, I took some shots that morning too, and you could see it turning color as well. It was redder when it was down in the murk, but definitely darker on the side closest to the umbra.
I was just trying to make do with what I could when I was offshore.
I think it's great.
Oh, I thought it was excellent. Okay, I think that's all the pictures anybody sent me. Hint, hint. I'm going to stop sharing my thing here. All right.
Kim, I could mention Kim. I don't know if you realize what Jim was saying. Jim is working offshore on an oil rig, controlling his telescope remotely.
That's good. A lot of us would like to do that.
Yeah.
I think it's kind of nice that his wife's willing to go out and take the tarp off the telescope for him and all that. I'm impressed, Jim.
I think it's nice too.
Any other visual observations? Anybody seen anything? Want to put up their hand or open their mic and take in?
I can show a few things.
Okay. Geez, now, Nikolai. Okay.
Yeah, I can share a screen.
Okay.
Can you see that?
Yeah.
Okay. I actually wasn't going to show anything, but then Kim's excellent talk inspired me to show some of my solar pictures that I've taken. They're not current, and there's only 3 of them that I'll show. And I'll also show some of the sketches that I've done because I don't know if I've actually shown them to this group before. This is the first picture that I was going to show of the sun. So this is, can you see this?
Yep.
Okay. So let's go. So this is April 15th, 2016. A stack of 4 pictures. The light was artificially added because I was posting this on social media, so I wanted it to look better. I did specify that. But if you zoom in, that was, I believe that was one of the more famous, I can't remember if that was the Mickey Mouse sunspot. There was something about that, but pretty decent group of sunspots there. And so that's one. This is another one that was actually from the transit of Mercury in 2016, May 2016, which of course, Mercury itself is the attraction in this picture with the black drop effect here. But for comparison, here are the sunspots at the time. Of course, we were all hoping that Mercury would cross over or very close to a sunspot, but that didn't happen. But it's still cool to see the comparison, you know, size, brightness, etc., or darkness, I should say. And then there was the Newfoundland was very lucky to or St. John's was very lucky to have good weather for both transits of Mercury. The one in 2019, we had some clear skies for it, but unfortunately there were no sunspots there because that was, at the very bottom of that minimum. And the one from the solar eclipse, which is not a picture taken through a telescope, that's just me pointing my camera. So that's in Idaho in 2017. The fully eclipsed sun here, literally in the middle of nowhere, with cars parked and people just looking at it in awe. The 360-degree sunrise, sunset, whatever you want to call it. And that was pretty amazing. So that's what I was going to show for pictures that I've taken. I will stop sharing now, and now I'm going to show you some of the sketches that I've taken. There's only 3, I think, but just to see, let's see if you can. Oh yeah. See, mine are very rudimentary because I was just learning how to sketch, and they're not very impressive, but they still show. I don't know if you can see that very well. So the plus is the center of the sun. This was actually quite active, as you can see. There's pretty good group here with one of the spot groups having quite a bit of detail. And I actually describe, in a fair bit the detail what I saw here. So that was one thing that I was going to ask if Kim, if older observations are, valid for submitting, because I actually haven't submitted those and I got inspired to do that.
Yes, they are.
Okay.
They may not be included in the most recent bulletins, but they are, because that still gives a picture of what the sun was doing at that point in time.
Okay.
So somebody may not have got that time that you did your observation. So it fills in the gap.
Yeah, that's great. They're not overly old. They're 2014. Here's another one. It's not as sharp as, maybe the focus is not right, but it actually is a lot sharper than it appears on the camera. So I've been doing mostly planetary. There's not as much sun, but this is that famous triple transit on Jupiter. Or is it? Yeah, that's the triple transit.
Yeah, that's nice. That's very good.
Yeah, I've been taking actually quite a few sketches of Jupiter. That's the one that I mastered how to do, for it to actually be not only visually pleasing, but also scientifically accurate.
Yep.
I do need more practice with the sun to be able to do that.
I have a lot of issues with Saturn.
Yes. Yeah, I can relate to that. And this is the telescope that I have used for the pictures. So that's the Celestron 5-inch telescope, which my understanding now is that it might be slightly too big for that purpose. And this is the filter that I got back from when Canadian telescopes was a thing. So it just goes here. I did notice a few holes in it over time. So what I did was I put a little patch on it, and maybe Kim can advise if that's actually okay. I did some research, and it seemed like it's an okay thing to do as long as you cover it.
It just gets to the point where you may have too much on there and it won't be any good because you won't see anything. But I have one solar filter that the whole inside is just black dots. So yeah, okay, it's garbage. Go to the next one.
Yeah, I figured it's just one patch for now. So it should be okay for a little bit. And I'll think about upgrading, when there's more. But yeah, that's what I wanted to show for solar observing.
Very good. Any other observations before I go back to Nikolai to talk? Here's the pad I use to hook onto my scope for doing drawings at the back. I'm not using that. Anybody else?
You need to use it.
Just want to comment briefly that Gary, you showed a photograph of a sorry. One of my pictures with the Christmas lights on a house and Jupiter and Saturn. Well, after I took that picture, my 13-year-old daughter and I took her 5-inch reflector telescope out into the driveway, and we were both looking at the planets under some magnification. And happily, with the 25mm eyepiece, both planets were in the same field of view. So they were already close enough to see them both at once, and she thought it was pretty cool.
That's really good, actually. I had someone phone me up this morning. They had been up early and saw a sundog. At first, didn't know what it was and asked me. I was quite surprised, but when I told him to go, it sounded like a sundog because it was early. And when he looked at the Google and searched, he said, "Oh yeah, that's exactly what I saw." He'd been at sea for 60 years. He was telling me, right? But that was the first time he'd ever seen a sundog at that early in the morning. Well, the first time I've ever seen one, I thought. Type of thing. It was interesting. Okay, no more observations. Can we find out what's coming up, Nikolai?
Yes, we can. I'm going to share again. All right. Can you see this?
Yes.
Okay. See if I can make this full screen. How do I make it full screen? View. That's okay. Doesn't have to be full screen. So I did actually prepare this very last minute. It's been a crazy week. So if you see something odd or missing, please let me know. I will update it right away. So this is what you can observe from St. John's from now and for the next month approximately. So this is sun rise and set times. As you can see, the sun sets at 4:10 today, which is nearly, you know, as early as it can set. Bad for daylight, good for astronomy, you know, assuming good weather. This is solar system roundup for all the planets. And this is a current picture of the sun, which, as Kim very eloquently described, much better than me, is basically what you're seeing is the emergence of the sun and it going into the, was it the 25th cycle? And so we're actually seeing a slight uptick in activity with the southern hemisphere being the more active one. And there's actually 3 sunspots right now. So pretty good considering how it's been for a while. So that's the sun. We do have evening planets. Most of the planets right now are in the evening. We do have Mars, which drops below that unofficial threshold of 10 arc seconds, which is what people consider to be, you know, for observable detail. But it will basically remain a feature in the evening sky for quite a while. So that happens on January 4th. So until then, I guess it's slightly above 10 arc seconds. So you have whatever, 2-3 weeks. And then Jupiter and Saturn, of course, the thing that everybody's talking about and that you've heard many times. So I'm not going to repeat, but I figured I would provide a weather update because that's what I do and what people are probably more interested in. And from what I saw was that it actually doesn't look very good on the 21st. So there's a bit of a storm coming. So that's the bad news. The good news is that on the 20th, it actually looks pretty decent. And, you know, you don't actually need a whole lot. You just need a bit of a break to see that. I actually don't think that taking a picture through the telescope of the two would work because there's such different brightness. I could be wrong. Maybe there's a way to do it, but you know, if I feel like one of the planets would be overblown if you did that. So it's mostly a visual event, really. But yeah, they will be at its closest for the past 800 years. Uranus and Neptune will be visible in the evening as well. And we do have Venus in the morning, about 2 hours, rising about 2 hours before the sun for right now. And that will continue into January. In terms of comets, I actually just looked at this for the first time. I'm not sure if anybody has seen this comet, which peaks at magnitude 5.3 last week, which is pretty good. I haven't seen a whole lot on it. And then everything else is significantly fainter than that. Here's a list of asteroids, a list of supernovae on this website. I think the brightest one right now is 11 magnitude from what I saw quickly. The meteor showers, of course, we had the Geminids, which was clouded out and snowed out. These are the deep sky objects for December and January, both for telescope and binocular observing. So these are the highest things in the sky for these months. ISS passes right here. And finally, observing sessions, which are not happening. So here's your observing calendar for December and for January. And that is all I have. Are there any questions?
I guess not.
I could just mention, Nikolai, that Todd Baker posted a picture this afternoon, again from his driveway, and he had the same sort of observation. In order to get the moons of Jupiter, he sacrificed the rings of Saturn. So is either or, he was saying.
Yeah, they are what, two? Well, the moons, yeah, but the actual planets are 2 magnitudes difference or something. Or Jupiter is minus 0.2 and Saturn is 0.6. So it would be a challenge to get a visually pleasing picture. So yeah, it's just a visual event, really.
That same storm you're talking about, is that the nor'easter is going to hit most of the Northeast?
No, I think that's tomorrow.
Okay.
Yeah, that's tomorrow, the one that's hitting New England and part of Nova Scotia. The one on the 21st is a different one, I think. Unless you're talking about another one, which is possible.
Well, this time of year, right?
Yeah. So, thanks very much. Stop sharing your screen there. Thank you. Randy, is that the agenda?
That's pretty much it. I can't see who the attendees are because I'm locked into this, but we have a new member. I don't know if Jody is on there. Maybe you could mention. No. Okay, and we also have a visitor.
Oh, yeah. Who's our visitor?
Okay, there's something just popped up on chat. Chris, are you looking at what's on the chat?
Well, it's Kim saying, lovely sketches, everyone.
Yeah, I was just going to say, sorry, I was muted.
Okay.
You saying cool sketches, Nikolai, well done. Kim saying lovely sketches, everyone.
Okay.
And And I think our visitor is Shaziana. Is that pronounced correctly?
Yeah, well done. That was correct.
Okay.
It's nice to be here. Thanks for inviting me.
Welcome.
You bet.
Maybe you could introduce yourself.
Sure, yeah. So I'm Shaziana. I'm a master's student at McGill, but home is Newfoundland for me. So I actually just came back on Monday for the holidays and to stay here for hopefully a couple months. So I'm in quarantine in my basement. And yeah, so I'm doing my master's. I just submitted my thesis last week on space situational awareness and space flight dynamics. So I looked specifically at detecting and characterizing spacecraft that complete unknown maneuvers in space. So a spacecraft might move into the vicinity of other spacecraft without people in that area knowing that that's happening, and that poses collision risks. So I'm looking at figuring out, did this happen? Why is it happening? And what's the intent? So I did kind of more of like an exploratory sensitivity study around that using filters and such. I did my bachelor's at Carleton in Ottawa, also in space systems engineering. And otherwise, I've been trying to put in some effort in space outreach and figuring out new fun and innovative ways to engage the public into being excited about space. I went to the International Space University last year. Yeah, I've been trying to get into astrophotography myself. I have a tiny little Halley-scope in Montreal with my little DSLR camera. I was able to capture neowise and the moon and Mars, Jupiter, Saturn, Jupiter's moons, but only as like tiny little specks of light. But yeah, so I think that's me in a nutshell.
That's cool.
That's really cool. Welcome aboard.
Thank you so much. This is really cool.
Sounds like a talk in the future.
Sure, I'd love to.
I wasn't going to say anything.
I got to. Scared her off now, see.
Yeah.
Sure, I'd love to. Let me know.
That's really neat. When's your defense? Do you know?
So in my program, I don't actually have to do a master's defense. It's only PhD students. I had to do a seminar. And so I did that back in October.
Cool.
And you have to do that before you submit your thesis anyway. So now I'm just waiting for the examination process, which will take at least 8 weeks. And then my final will be out by April. So
cool.
Job searching now.
Yep, you betcha.
Yeah. But also relaxing, which is pretty nice.
Yeah, it's nice. Nice to be home too.
It really is. Yeah. And because of quarantine, I have to get my food brought to me, which is really great.
Oh my goodness.
I think I'd like to try that myself.
It's nice.
It's sort of nice, yeah.
Sort of nice,
yeah. To be out and about, but yeah.
Yeah. The silver lining to the circumstances.
Yeah.
Yeah. So I'm hoping I can get out on my backyard for the conjunction or at least the day before, given the weather report, and see if I can see things. But,
yeah. Cross fingers.
Yes, definitely. Looking forward to it. For sure.
Okay. Thank you very much for introducing yourself.
Thank you.
Okay, Randy, are we at the end?
That's it. I just see there's a couple more chat comments. Chris, anything worth mentioning?
Every time I look away from the window, something new pops up. Sorry. Robert, to everyone. So you are a space detective. I guess he's talking about what you do, Shaziana.
I've never thought of it that way. I like that. I'm going to steal that and start introducing myself as a space detective now. So thank you.
Marcellus, great meeting, folks. Thanks, Ken. Got to go. And I think he's already gone.
Okay.
And Ken, to everyone again, congratulations, Shaziana.
Thank you.
So there you go. And I think that's all I have at the moment.
Okay, well, Merry Christmas, everyone.
Yeah, yes. Merry Christmas.
Yes, Merry Christmas, everyone.
Merry Christmas to you all.
Shake my horns at you all.
If you, we've got about maybe 5 minutes before we get cut off, so if anybody wants to chit-chat.
Kim, we do try to post these on our YouTube channel.
That's fine.
Takes me a little while to
yeah, they can be big.
Yeah.
Yep.
So and we have to add some things to them, the land claim stuff and everything, you know. So I did this, Kim, we did this as a center. I don't know, I don't hear much from other centers these days, so we made up a Christmas card. It's
That's
a
lovely.
5x7. I called it Memories of 2020. So we have our Zoom meetings.
That's good.
Some of us were chasing after that picture of the Cabot Tower with the moon behind it. That was, again, Brubaker did that. Little moniker we do, and Snowmageddon. And again, Magnificent Mars. On the other side, there's Neowise, of course. We had a great time with Neowise. And that's Nikolai's streetscape picture, which in real pictures you can see the comet, but in this one you can't. Blame Staples for that. And again, some Neowise. We had some great fun with Neowise.
Yes, it was a great comet.
Yep,
that was so cool.
Too bad we couldn't do any public outreach. So
yeah.
That's excellent. That's a beautiful card.
You'll get one.
Oh, thank you.
As soon as I get your address.
we're basically just we're trying to capture everybody's pictures from the center and going to be able to put them in like a yearbook. Is what we want to do, to be able to put them online, and that way you've got them, because everybody puts pictures to a list or something, but email lists go down or they lose the pictures, so it's always nice to have them in a central spot.
We have a groups.io mailing list as well, and I bought the extra disk space so we can store pictures on there as well.
Good.
Gary just fleeces them off there for his meetings. So
that's because nobody sends them to me anymore. I keep saying, send in your observations.
Yeah.
And nobody listens to me, and then they all go, what? Craig,
the other thing,
make a rum cake for the Christmas party.
Aha.
Can you digitize that?
Don't answer. I'll let you know. Kim, another thing we did, we restarted the newsletter.
Good for you.
So, since we're meeting like this, but it's online, of course. But we try to keep busy with people.
Yeah.
Sorry, my clock is ringing.
We've kept our newsletter going. We generally have had it online. We only send out maybe half a dozen because people don't have either the bandwidth to download it, or they're moving around, so they end up getting it by mail. But we haven't done a lot. Well, nobody's done any outreach. We haven't done anything with Queen's Observatory since February, because March, basically, it was that week that it was shut down. So we do our Zoom meetings once a month, but we have weekly social on Zoom. So it's only like maybe, an hour and a half, but you're basically just get your drink, relax, chit chat, and have a good time. Everybody shows what they've been up to, or if they've got issues with cameras or telescopes or pictures, or don't know how to process and that sort of thing. So that's what we end up doing.
Yeah, we've been doing a lot of hangouts. Members get together and say, oh, I'm going to process using this software. Anybody want to come and take a look and help?
Yeah.
And we get together that way. And we've had a couple of sky parties. People have set up their scopes and that.
Yeah,
that's,
we'd like to get into doing that, but it's too cold, right? We're wussies. I went minus 14 last night. Okay.
Okay.
But from what people I follow on YouTube and Twitter and stuff for their social media, there's been a lot of cloud all over, even Europe, cloud out for weeks on end, and Ontario as well. So it's not only here in St. John's that people aren't seeing much.
Yeah, yesterday was clear all day. So I was out doing some solar. Come sunset, you start seeing the stuff creep up over the lake.
Yeah.
We were out there for maybe half an hour. The wind picked up. It got pretty cold. And then the cloud came in, and that was it.
Yeah, all she wrote.
On Monday is total solar eclipse in South America. Apparently, anybody's wondering if there are going to be any decent pictures because it was cloudy in Chile.
I saw a beautiful one. It was
okay, good.
H alpha one. You know, the horny sun with things coming off the sides and everything. So it was from Argentina. Chile was Chile was clouded out, but Argentina was fine, right?
I had booked vacation for that one earlier this year, and then COVID happened, and I canceled my vacation.
Oh my!
Yeah, we watched it live on TV.
Yeah,
not the same.
But you had a vacation, Nikolai. You had a vacation.
Oh yeah, it just wasn't.
No.
In the path of totality.
Yeah. Well, we get about 60 odd% totality next June. So that's a
good month for clear skies in Newfoundland.
It's at sunrise as well, so even worse, right?
Oh, fox season.
I should mention a lot of people may have missed that the RASC has brought out a new publication. It's sort of a mini handbook. There you go. It's got a couple pages of the sun in it. So it's got a lot of the same stuff that's in the handbook, but it's got pictures and but not as much like what's up this month and sort of stuff. But it's a few bucks cheaper than the handbook. And so I guess it's a combination with Firefly.
Yeah.
So is it all one author or is it a compilation of authors for that?
It's mostly RASC people. There's the editor, I guess.
Nicole Mortellello put it together.
Okay.
Oh, okay.
But there's a combination of a lot of people and a lot of people's pictures. So.
Yep.
But that just means it's going to be a yearly thing since it's the 2021 almanac. We're going to end up with 2022.
I wonder if that will hurt the Observer Handbook.
I think they did it because the Observer's Handbook is a lot more detailed. And I think they're trying to use this more as trying to get the everyday person to look at the sky. I mean, you've got Sky News, and that's great, but Sky News doesn't go into, the constellations and pictures in the constellations and that sort of thing. So I think it's just more or less an outreach book.
Sort of like what astronomy and Sky Telescope about once a year. They're all right?
Yeah.
Okay. Interesting.
I don't know if any of you read Sky at Night, the BAA, or the, not the BAA, but the British magazine.
TV show?
Magazine, BBC, yeah. Well, yeah, we watch that. And so I download the online magazine on my tablet, and you can read it. It's got a lot of good tips in there, a lot of information for science, big science information, but it's also got a lot of do-it-yourself projects and a lot of reviews on telescopes or binoculars or eyepieces or books and that sort of thing. So it's, for $8.49, and plus you can get it right away instead of having to wait 2 months to get it by paper. Yeah, it's good.
Okay.
Yep.
So, nobody wants to chit chat? Everybody talked out? That's odd for you guys. Must be
Can I share my screen for a second?
Sure.
There you go.
Oh, there you go.
There we go. Oh yeah.
What do you think of that?
That's something.
That's super cool.
It's got everything you want there, Kim. In half the sun. I don't know who to give credit to. So that was on Space, Science, and Tech. So that's Eduardo S. Pupo, is it? Yeah. in Argentina.
It's Monday, yeah.
Mm-hmm.
Wow.
Nice.
Nice.
So there.
Very nice.
Okay. I'm stop sharing. Am I?
Yeah.
Yes.
Okay.
Wait.
Okay, guys, I'm gonna go.
Yep.
Have a good
Thanks very much,
Christmas.
Kim.
Thank you,
Thank you.
Kim.
Right.
Thanks,
We'll see
Kim.
you later.
See ya.
Okay, take
Christmas.
care.
Bye.
All right.
Bye.
Okay. I'm saying goodbye too. Bye. Okay. Good nights.
Well, folks,
Bye.
thank you. Have a good one.